Welcome to the 48th lecture of Digital Electronics subject. So in this lecture we are going to realize full adder using NOR gates only. In the previous lecture we have realized full adder using NAND gates only. Now coming into the basic expressions of full adder. So we have realized this min-term and max-term expressions of full adder. So sum is in min-term form, that is sigma m 1247, and carry is sigma m 3567. So coming into max-term expression, sum is equal to pi m 0356 and carry is pi m 0124. That is again in max-term expression form. And we have realized the expression of full adder as full adder we have realized the expression was sum and carry. So sum you got a C in into A XOR B, A XOR B, or C in bar and A XOR B, and or that can be simplified as A XOR B XOR C in, and carry is basically you will get the C in and A XOR B or AB. Okay, so that is a basic introduction to this half adder, and we have realized it using XOR gates, AND gates, and AOA gate. Then in the last lecture we have done with NAND gates. So in this lecture we are going to deal with realization of full adder using NOR gates only. Realization of full adder using NOR gates only. Realization of full adder using NOR gates. So here what I am going to have is, what is the expression for sum? Okay, sum is basically C in H bar or C in bar X, where H is equal to A XOR B. Okay, that is already dealt in lecture number 47. And carry I can write it as C in X or AB. Okay, so these two are the basic expressions which we are going to play upon. Now let me come into the form of representation of this NOR gates. Yeah. Okay. Now, if you are going for this POS form of representation, of sum. So I am going to write into the expression number 1, and this is expression number 2. Now to derive the POS form of sum, okay, I am drawing a K-map. Okay. This is X C in 0 1 1 0. This is C in Z in bar, H bar X. Okay, 0 1 2 and 3. So what is the first term? First term what I have is C in H bar. So here you will get 1. Next one is C in bar X. This is 1. So these two expressions are basically in SOP form. So I am trying to convert it into POS form, the sum. Okay. So this is the sum. I am going to convert it into POS form. Okay. Now coming in, now where will be zeros? Zeros will be here and here. Okay. So if you are writing the POS expression, this will be X, this will be X bar, this is C in bar, and this will be one second. There was some mistake. There is a blunder mistake. What happened? Some mistake happened there. Okay. One more time. I will draw the K-map. Okay. So the two variable K-map. So here what we have is H C in 0 1 0 1. So this is 0 1 2 and 3. So this is H bar X, C in bar, C in. First term is C in H bar, So this will be 1. C in bar H. So this will be 1. All others will be 0. So this is basically in SOP form. Now to derive the POS form, what we need to have is we need to take zeros. So here we are having 0, here we are having 0. Here, this will be H, this will be H bar, this will be Cin, and this will be Cin bar. Therefore, sum in POS form, you can write it as sum is equal to, you take this 0, what is it? X or Cin and this one, H bar or Cin bar. H bar or Cin bar. Okay. So that is the sum in POS form. That is from sum in POS form. Now coming into sum. Okay. Taking the complement of that, sum complement. What is it? That is H or Cin and H bar or Cin bar, the whole complement. What is it basically? That is basically H or Cin, the whole bar, or H bar or Cin bar, the whole bar. That is according to De Morgan's law. So this is basically the complement of sum. Therefore, sum you can write it as complement of sum and its complement. That is sum bar bar. What is it? That is H or Cin bar or H bar or Cin bar, the whole bar, the whole bar. This is basically in NOR form. This is basically in NOR form. So you got sum in NOR form. Now coming into carry part. Coming into carry part. What is carry? That is Cin X or AB. That is carry. So what is carry? Carry is, again you can write it as carry bar. Carry bar is, you can write it as Cin X or AB bar. Okay, so what is it? Okay, so you can write it as that is Cin H bar dot AB bar. So if I am rewriting this, here what will I get? That is Cin bar or H bar and this A bar or B bar. So that is carry bar. So what happens to carry? So carry is Cin bar or H bar dot A bar or B bar, the whole bar. Okay, but we have not reached the final condition. That is again what? So that what we get is that that is Cin bar or H bar, the whole bar, or A bar or B bar, the whole bar. So you got the carry. But again, what is carry bar? Carry bar I can write it as Cin bar or H bar bar or A bar B bar bar, the whole bar. Okay. Again coming into carry, what is it? That is Cin bar or H bar whole bar or A bar or B bar, the whole bar, complement of that and again complement of that. Okay. So that is basically in NOR form. So that is basically in NOR form. Okay. From there we are getting the expression of carry. Okay. So now let me rewrite. Now what is X then? Now if you are writing X, okay, what is X? That is a question there. So X is again this H or gate. So X you can write it as A H or B. So what is it? That is AB bar or AB. Okay. So if you are writing X in NOR form, you can write it as A or B bar or A bar or B bar the whole bar. That is on comparing with the expression of sum. So that is H is also in NOR format. Now coming into realization using NOR form. So I can write x. First I will write x. X is equal to a or b bar or a or b bar or a bar or b whole bar or a bar or b bar the whole bar. Okay. So that is x. Now what is sum? Sum is equal to h or sin bar or h bar or sin bar the whole bar. That is sum. Now coming into carry. What is carry? Carry is given by sin bar or h bar the whole bar. Sin bar or h bar the whole bar or a bar or b bar the whole bar or a bar or b bar the whole bar. Okay. Take bar of that and again complement it. No combination of that and again it's complement of that. Okay. So you got carry. Now I am going to realize this realization of full adder using NOR gates only. Realization of full adder using NOR gates only. NOR gates only. Okay. So that is what we are going to realize. So we are having A and B as input. A and B and C as input. So first you realize x. So what we have is A x NOR A NOR B. A NOR B whole bar. Next one is a bar or so here you need to take a bar as well as b bar. Okay. So you need so take the two inputs. So here what you get is a bar. Again here you take a NOR gate. You will get b bar and take NOR of that. Yeah. So what is it? That is a bar or b bar the whole bar and take NOR of that too. Taking the NOR of that too, you will get h. So h is ready. Now next one is h XOR C in whole bar. H is ready. So this is h. Take a NOR here. So this is h NOR C in, then h bar. So you have another thing. So here you have two same inputs with a NOR gate. So you get h bar. Here you will get C in bar. Okay. Now you note that too. Okay. Now you note that too. Again NOR. Here you will get this is h bar or C in bar the whole bar. Now you NOR that two terms. So NORing that two terms, you will get sum. Okay. So that is just for sum. Now what is carry? C in bar or h bar the whole bar. That is here. Now a bar or b bar the whole bar. That is also here. Okay. Now you take so NOR that too and take the complement of that. So I am NORing that too. NORing that too and again take the complement of that. So we will get the carry. Okay. So this is realization using NOR gates only. Here again if you are looking into this, you can see that this much part that forms a half adder. Again, looking into this part, that forms another half adder. Okay, so now we can realize that, again, full adder is a combination of two half adders. Okay, so that is a realization of this full adder using NOR gates only. So by this lecture, I am ending with the lectures on full adder. So in lecture number 46, we have introduced what is a full adder and from the AOA logic and XOR logic. And in lecture number 47, we have dealt with the realization of full adder using NAND gates only. And in this lecture, that is lecture number 48, we have realized this full adder using NOR gates only. So in the next lecture, we will be starting with subtractors. We have full subtractor as well as half subtractor. Thank you, and wishing you all the best for the next lecture. Thank you.